In this tutorial video, we're going to talk about the properties of polygons. So here's the definition of a polygon. So it has to be a closed figure formed by a finite number of coplanar segments called sides. And before we keep going, let's back up because finite is a really important word. Finite just means that it's measurable. You can count the number of sides that there are. It's not infinity, it's something that you can count. That's what finite means. We already learned coplanar, but just to refresh your memory, coplanar means that these are sides that are all on the same plane. So let's go back through this one more time. So it's a closed figure formed by a finite or measurable number of coplanar on the same plane segments called sides such that, so the first condition is that the sides with common endpoints are non-collinear. So to refresh your memories, non-collinear means not on the same line. Not only that, but each side intersects exactly two other sides, but only at their endpoints. So most polygons, I think, you have seen before, but this is the polygon. Okay, I assume that all those lines are straight. That's my intention. So notice all of them are on the same plane. I did not make this tutorial video on two different iPads that somehow were on different planes. This is all on one plane. Notice that you can count the number of sides that there are. So it has a finite number of sides. It has 1, 2, 3, 4, 5 sides. All of the separate sides are non-collinear. So this right here is its own line. This right here is its own line, and so on and so forth. Okay, they're all their own lines. The other thing is each side intersects exactly two other sides, but only at their endpoints. So notice you pick any of these sides here, and it ends where two other ones begin. Okay, so this line intersects two other sides, but only at the endpoints. So that's the general definition of a polygon. The other part of polygons that we have to make sure that we understand is that each intersection of sides, like right here, or right here, or here, or here, or here, are called vertex points. These are vertices of the polygon. Okay, just like triangles have vertices, so do polygons. The other part of a polygon that must be true is that it must be convex. Has to be. It cannot be concave. A really easy way to think about that is if it's concave, it means that there's a point, a vertex of your polygon that's actually inside the figure. So let me draw an example of a concave picture of a polygon so you can see the difference. Alright, so a convex figure is like the figure I just drew. Five-sided shape, it's a pentagon. Okay, all of the endpoints are pointing outward. Okay, from the figure, they are all going outward. Whereas concave, like a cave is, that's where that word comes into play, is one of those points, at least one of them, has to be going inwards toward the polygon. So for example, I'll still make a pentagon, so here's 3 of the 5 sides, but then it goes inwards. So this vertex is going outwards, this one's going outwards, and so is this one, and so is this one, but this one is not. It's going inwards like a cave. And anytime you have a condition like this, it cannot be considered a polygon. Not going to happen. Alright, so the next thing we want to talk about is what do we actually name these polygons? How do I know what I'm talking about? So there are several polygons all the way up to 12 that have specific names. After 12, you just call them by the side that they have and say "gon" afterwards. Let me show you the first 12 names of your polygons. Alright, so let's quickly go over the names of all of our polygons. Three-sided figures are called triangles. Four-sided polygons are quadrilaterals. Five-sided polygons are pentagons. 6 sides, hexagon. 7 sides is a heptagon. 8 sides is an octagon. 9 sides is a nonagon. 10 sides is a decagon, just like a decade. 10 years, 10 sides. Moving on, 11 sides, hendecagon. 12 sides, dodecagon. So if you have anything above 12, like 38 or 42, you just say 38 gone, 42 gone, etc. So that's how we are going to name our polygons. Okay, one more thing to cover with these polygons. We can either name them as equiangular or equilateral. Equiangular is exactly as it suggests. Equa in both of these words means equal. They're the same. Angular means angle. Lateral means side. So you can have polygons that are equiangular, which means that they have all the same angle measures. In other words, all the angles are congruent. Equilateral means the same exact thing but with their sides. So all the sides are congruent. So there's actually a condition that happens if you have both of these happening at the same time. And that is given a very special name called regular. So it's not so special. But they're called regular polygons, and that means that that polygon has both equiangular and equilateral properties. And it makes them special, because not all polygons are that way. So I believe that's really everything that we have to know about polygons for now, which means that this will conclude our polygon tutorial.